All right, welcome to chapter 10.4, which is all about fission and fusion. So this should be a recap of what we learned last week in class. So we know that nuclei stay together because of the strong nuclear force. Normally, protons, all positively charged, want to move away from each other. They repel because they're the like charge. But over really short distances, the strong nuclear force can overcome that and keep protons and neutrons together in the nucleus. However, if the nucleus gets too large or has too many neutrons, the strong force cannot overcome the electric force between the protons and it becomes unstable and wants to fall apart. And this is what causes radioactive decay. When a nucleus decays, it falls apart and it transmutates into a new, smaller element. And this is called fission. Fission produces a tremendous amount of energy as it breaks down from one large nucleus into two smaller pieces. This is how nuclear power plants work, although a big downside to this is that they leave behind nuclear waste. As a nucleus undergoes fission, it releases energy and free neutrons. These neutrons interact with the other nuclei around them, making those new nuclei unstable and starting the process of fission once again, which is called a chain reaction. And we can actually see that chain reaction happen in this really cool demonstration. This is a uranium-235 nucleus. It's not very stable, but if we shoot another neutron at it, it becomes very unstable and it undergoes fission. It falls apart. Now, if we have more than one nucleus that we start with, as one falls apart, it emits more neutrons, which can then interact with other ones in a giant chain reaction. Now, all of those yellow circles you see are energy bursts that are being let go. So you can see why a chain reaction would release a lot of energy. This energy, when contained, can be used in a power plant to give us electricity. And when it's uncontained and it gets out of control, that's how we get atomic bombs. Now, fusion is very similar to fission in the fact that they both release large amounts of energy and they are both the transmutation of elements. But fusion is different because instead of one nucleus breaking apart, it is two nuclei coming together under tremendous pressure and temperature to form a bigger nucleus. This is why the stars shine in the sky. The energy released in the fusion reactions inside the core of those stars leaves the surface in the form of light. Stars can fuse elements as light as hydrogen all the way up until iron. And as those heavier nuclei are being made from the lighter ones through the process of fusion, the energy is released in the form of heat and light. Now, you have some homework for tonight. Page 315, questions 1 and 6, and page 319, questions 19 and 32. So go ahead and answer these and have them ready for tomorrow.